Good morning. I am Priya JS, Assistant Professor of Mar Ephraim College of Engineering and Technology. Now let's discuss the topic delta modulation in communication system. So why go for delta modulation? So we know pulse code modulation where each sample is represented by means of n binary digits. Therefore, the signaling rate and the bandwidth required for transmitting the pulse code modulated signal will be more. In order to overcome that disadvantage, we go for delta modulation where single bit is transmitted per sample. Now let's go to the slides. So delta modulation because of the disadvantages of pulse code modulation. In a PCM system, n number of binary digits are transmitted per sample. Hence, the signaling rate and channel bandwidth of PCM are very large. Also, the encoding, decoding, and the quantizing circuitry of PCM is complex. This led to delta modulation. In delta modulation, only one bit is transmitted per sample. That bit is a 1 if the current sample is more positive than the previous one, and a 0 if the current positive is negative than the previous sample. So, a little information is transmitted. Therefore, in delta modulation require higher sampling rate than PCM. So, for ensuring the equal quality at reproduction or at regeneration, the higher sampling rate is preferred at the transmitter section. This scheme sends only the difference between the pulses. If the pulse at time Tn plus 1 is higher in amplitude value than the pulse at time Tn. So compare the sample values at Tn plus 1 and Tn. Then a bit 1 is transmitted to indicate that the difference is positive. If the difference is negative, a 0 is transmitted. This scheme works for small changes in signal values between the samples. So that's what already said. They have the adjacent samples should vary only in small values. For that, we are going for higher sampling rate. If these changes in amplitudes are large, this will result in large errors. So now let's see the example of a delta modulation waveform. So here this x of t represents an analog signal which is to be modulated, and we are here a reference signal, a staircase approximated signal is used. So at this instant the message is less than the staircase approximated signal, therefore the step size is reduced by del. At this instant the message is higher than the approximated signal, therefore step size is increased by del. At this instant again the message is increased, therefore step size is increased. So whenever the message signal is higher than the staircase approximated signal, the step size will be increased, and whenever the staircase approximated signal is higher than the message, or the message signal is lower than the staircase approximated signal, then the step size is reduced by del. This is what you can see here. In all the places the step size is reduced, and here step size is increased, then reduced, increased, then reduced. So whenever the step size is increased, a 1 is transmitted, and whenever the step size is reduced, a 0 is transmitted. Whenever step size is reduced, 0 is transmitted, and whenever step size is increased to del, a 1 is transmitted. So this is the delta modulation waveform. So now let's see the diagram of a delta modulator transmitter as well as receiver. So first let us see a transmitter. A transmitter consists of a quantizer, a 1-bit delay element with 2 summer. So see the first summer. Here x of nts is the sampled version of the input message signal x of t, and x cap of nts is the approximated version. So now E of nts will be the difference between x of nts and x cap of nts. This quantizer output B of nts will be either plus del or minus del depending upon the error signal E of NTS. When E of NTS is positive, B of NTS will be plus del. When E of NTS is negative, B of NTS will be minus del. And this is given as the input to the summer along with the previous output of the delay element un minus 1 ts. Both are added to give the input to the 1-bit delay element u of n ts. So after the delay, this will be un minus 1 ts, and this is applied as the one input to the summer. So figure shows the block diagram of a delta modulation transmitter. X of NTS is the input signal and X cap of NTS is the approximated signal. Error signal E of NTS is the difference between input X of NTS and X cap of NTS. 1-bit quantizer B of NTS output will be either plus del or minus del depending upon the error signal. The output is a delta modulated signal. Now, coming to the receiver diagram, it consists of the same 1-bit delay element, a summer with a low pass filter. So, this summer will add the B of NTS, that is the output of the delta modulator, plus del or minus del, along with the delay element output U of n minus 1 TS. So delta modulated signal is added with 1-bit delayed reconstructed signal U of n minus 1 TS, that is this is the accumulator operation. The reconstructed signal is then passed, this U of NTS is passed through low pass filter for smoothing. The cutoff frequency of the low pass filter is equal to the highest signal frequency in X of t. So this is a diagram of a delta modulation receiver. So now let's see the types of errors possible in delta modulation. Two types of quantization errors are encountered in delta modulation. They are slope overload distortion and granular noise. So this is what a delta modulation waveform, and this is X of t, the message signal. So this is the staircase approximated signal U of t. So let the message signal is like this. The signal is increasing, step size is increasing by del because the message is higher than the step signal. But you can see it is not following the input message signal because the step size is not that much big. So because of the small step size, there occurs an distortion in the delta modulation waveform, which is called slope overload distortion. So slope overload distortion arises due to the steep message signal or the fast slope in the message signal, or we can say the step size del is not that much large to keep in pace with the message signal. So now see this part. Here the message is almost a constant, but the staircase approximated signal is swinging up and down. So when we see the bitwise representation or delta modulated binary sequence, so this part will be 1 0 1 0 etc. Even though the input X of t is a constant, in the output of delta modulator, the output may vary or swing between 0 and 1 because of the large step size. So we can conclude slope overload distortion occur due to small step size and granular noise occur due to large step size. So these problems can be eliminated by a new modulation technique which is called adaptive delta modulation. So in delta modulation, step size is fixed, whereas in adaptive delta modulation, step size is varied depending upon the variation in the message signal. That's how the slope overload distortion and granular noise are overcome. So slope overload distortion arises because the rate of rise of input signal x of t is so high that the staircase signal cannot approximate it. The step size del becomes too small for staircase signal u of t to follow the steep segment of x of t. Hence, there is a large error between the staircase approximated signal and the input signal. So you can see there is a large error between the x of t and the staircase approximated signal u of t. This error is known as slope overload distortion. To reduce this, step size must be increased when the slope of the signal x of t is high. Next type of noise is the granular noise or idle noise. This occurs when the step size is too large compared to the small variation in input signal. This means that for very small variations in the input signal, the staircase signal is changed by large amount because of large step size. So in order to avoid granular noise, we have to pick small step size. So advantages of delta modulation. So due to transmission of 1 bit per sample, it permits low channel bandwidth as well as low signaling rate. ADC is not required. It is analog to digital conversion. Is not required, thus permits easy generation and detection. Disadvantages of delta modulation that leads to slope overload distortion and granular noise. Then application, it is widely used in radio communication devices and digital voice storage and voice information transmission. So mainly it's used for voice transmission where signal quality is less important. Then how to overcome the drawbacks of slope overload distortion and granular noise. A modification of delta modulation is the adaptive delta modulation where the step size is not fixed, it is varying depending upon the input message signal. Okay, thank you.